Hello, welcome to AP Calculus Lecture 5.5C, where we're going to go over applications of exponential functions. We'll be working a couple of problems from page 355. This really isn't calculus. You might have done these types of problems in pre-calculus or a financial literacy type class. But yeah, let's just do a few examples. Very short lecture today, so okay, we're going to learn about the compound interest formula. Okay, you have to memorize this formula, but it is A is equal to P times 1 plus R over N to the N times T. So to define these variables, A is equal to the future value, probably stands for accumulated value, but it's the future value. P is the present value or current value, because money has a time value. R is equal to the interest rate. N is the number of compoundings per year. So how many times is your interest compounded every year? All right, and then finally, T is just the time in years, so the number of years. So if it's half a year, you'd put 0.5. Okay, let's do example 54 on page 355. So it is a table. Put it into view here. So you've got a table here, and it says complete the table to determine the balance A, so that future value for P dollars, the current value or present value invested at a rate R for T years, compounded N times per year. So we're not going to do all of them. We'll just do a couple of them. But, oh, by the way, before I do this example, I need you to write one more formula. I'm so sorry about that. You can also have continuous compounding, so the continuous compounding formula, and we're going to use this in number 54 also, is A is equal to P E to the RT. So PERT. You need to memorize that as well. So A, P, R, and T are the same as up here. So memorize both of those. So now we'll do example 54. So what I want to do is let's do N equals 1. We'll do N equals 365. And then we'll do continuous compounding. So for N equals 1, we're trying to find A. Our present value is $2,500. Okay, so just read there, present value $2,500. So plugging into the formula, A is going to be $2,500 times 1 plus, the interest rate is 6%, so that would be 0.25. 0.06. The number of compoundings per year is 1. And then we have 1 compounding per year, so N, and then T is 20 years. Okay, so if we were to put that in the calculator, so it's going to be 2,500 times, I'm going to put this in parentheses, it's just going to be 1.06, right? 1.06. We're going to raise that using the caret symbol to the 20th power. So we'd have $8,017.84. So if we compound once a year, after 20 years, $2,500 would grow to $8,017 at a 6% interest rate. Now let's say you were compounding daily. If you're compounding daily, that's 365. So A is going to be 2,500 times 1 plus 0.06 over 365 raised to the, so raised to the compounding 365, so that's N, and then T is still 20 years. So this is going to take a little more care to put in our calculator. That would be 2,500 times, I'm going to put a left parenthesis, 1 plus another left parenthesis, 0.06 divided by 365, right parenthesis, so all of this we're putting in parentheses. Close the overall parenthesis, okay, and then we're going to raise that to the 365 times 20. So you can see your calculator puts both that operation all in the exponent. And that's going to be 82.9947. So more compoundings, more money. Not a ton more money, but a little more money. And then if we have N is continuous, we would have A is equal to P, 2,500, times E to the rate, 0.06, times time, which is 20. So that's 2,500 times E is, you hit the second function and then the natural log. You've got the E, 0.06 times 20. You'd have 8,300, so it's a little bit better. $8,300.29. So just a little bit better than daily compounding. But continuous compounding is always going to be your best bet if you can get it. All right, let's, I'm just going to erase this little part here. We'll do example 60. So example 60 says, assume that you can earn, 60, we have, in exercises 57 through 60, complete the table to determine the amount of money P that should be invested at rate R to produce a balance of 100,000 in T years. And number 60 says we have the rate is 7% and it's compounded daily. Okay, so we're just, instead of finding A, we're going to be finding P. So A is 100,000. That's how much we want to get. That's equal to P times 1 plus, our interest rate is 0.07, so 7%. It's compounded daily, so 365 raised to the nt, so 365, and the time is, let's see, 10 years. So on this example, we're not going to fill out the whole table. We're just going to do 10 years. Okay, so P is going to be $100,000. Just doing the algebra here. I'm going to bring this entire thing underneath the 100,000. So that's going to be 1 plus 0.07 over 365 raised to 365 times 10, right, would be 3650. Okay, so let's put that in the calculator. So it'd be 100,000 divided by left parenthesis 1 plus left parenthesis 0.07 divided by 365 right parenthesis again, raise that to the 3650 power. All right, and you get $49,661 and 86 cents. So it's really just know the formula and then don't mess up on the calculator. Be careful with your parentheses. You're going to need a set of parentheses around this as well, and close that parenthesis. But yeah, those are the kind of problems you'll be doing on the homework. But then there's a couple of others I want to go over. Okay, so let's take a look at example 64. And we'll do both A and B. So 64 says, in a group project in learning theory, a mathematical model for the proportion of P correct responses after N trials was found to be this. Find the limiting proportion of correct responses as N approaches infinity, and then find the rate at which P is changing after N equals 3 trials and N equals 10 trials. So we have P is equal to 0.83 over 1 plus e to the minus 0.2 times n. So we want to find the limiting proportion. So we're going to take the limit as n approaches infinity of 0.83 over 1 plus e to the minus 0.2, and then think of an infinitely large number there. Okay, if it's a negative exponent, so this would be negative infinity, right? It's going to be the limit as n approaches infinity of 0.83 over 1 plus, that's going to be 0.2 times infinity would be negative infinity, right? So that's negative infinity is the same as 1 over e to the infinity, right? 0.2 times infinity is just infinity. And because it's negative, we're going to make it in 1 over the. So that 1 over e to the infinity is just, it goes to 0, right? 1 over an infinite number is just approaching 0. So the limit is going to be 0.83 over just 1 plus 0, which is 0.83. So what that's saying is that your best case scenario of percentages, proportion of correct responses, if you did this exercise for an infinite amount of time, the best you're going to do is 83%. All right, and then 64b says find the rate at which P is changing after 3 trials and after N trials. So we need to take the derivative for rate of change. So P prime of N is going to be, this is a chain rule, so it's the bottom 1 plus e to the minus 0.2n times the derivative of the top, that's a constant, so it's 0, minus the top 0.83 times the derivative of the bottom. Well, the derivative of 1 is 0, and the derivative of e to the minus 0.2n is e to the minus 0.2n times the derivative of the blop, or that exponent, so times negative 0.2. All over the bottom squared, 1 plus e to the minus 0.2n all squared. Okay, so this all goes to 0. And then you have a negative here and a negative here. So what we're going to plug in, p prime of 3 is going to be 0.83, because those two negatives cancel out, times e to the minus 0.2 times 3 over 1 plus e to the minus 0.2 times 3 all squared. So putting that in our calculator, we would have 0.83 times e to the negative 0.6, right? 0.2 times 3 would be negative 0.6. That's 0.4555. And then the bottom is 1 plus e to the negative 0.6. And then we're going to square that. So that's 2.3988. So I would have the 0.4555 number divided by this 2.3988 number. Oops. I'll just type it in. So you have 0.189. So I think I did something wrong there. Oh, I forgot to multiply by the 0.2. I'm so sorry. So times 0.2. My apologies there. So that'd be 0.83 times e to the negative 0.6 times 0.2. So that would give you 0.0911. And then we're going to divide that by 2.3988, and that's 0.038. So this, the proportion of correct answers at time t equal 3 is changing at a rate of 0.038. And I don't know what the correct response is per trial, I guess would be the unit there. So that's, and then p prime of 10, you would just do the same thing, 0.83 times e to the minus 0.6 times 0.2. Actually, it wouldn't be 0.6, would it be minus 0.2 times 10? So that'd be negative 2 over 1 plus e to the minus 0.2 times 10 all squared. So you would go through that, which we didn't really need to do. 0.83 times e to the -2 times 0.2. That's 0.022465. And then 1 plus e to the -2. And we're going to square that. We get 1.289. Alright, so let's see if I can do it this way. So we'd have that divided by that, and 0.017. Okay, so that does it for this lecture. Let me go ahead and give you the homework. Didn't really need to work the one when we got p prime of 3. I probably should have stopped there, so plugging in 10 wasn't really necessary. But the homework is page 355. I want you to do 51A. '53. Just do n equals 2 and n equals 365. 57. Do n equals 2 and n equals, do n equals 10 and n equals 50. 59. Do 10 and 50. So just fill out 2 parts of the table. And then do 61 and 63. Those are 61, do all 4 parts. So that's an interesting one. And then 63 is kind of like example 64. So example 64 was to help you with 63. All right, that does it for this lecture, and I will talk to you on the next one.